Hello friends, welcome to my channel. Let's have a look at problem 1367, linked list in binary tree. In this video, we're going to share a solution based on binary tree traversal. So first, we'll read through the statement of the problem, and then we're going to do some simple analysis and share the code. First, let's look at the statement of the problem. Given a binary tree called root and a linked list called head, so return true if all the elements in the linked list starting from the head correspond to some downward path connected in the binary tree. Otherwise, return false. So in this context, downward path means a path that starts at some node and goes downward. So here are three examples. So example 3, the return is false, so no matching path. In example 2, 1 and 2, so the return are true. So in example 1, so the linked list is represented by 4 to 8 here. So it's indeed a path, but this path does not start from the root. So in example 2, so the linked list is 1, 4, 2, 6, and there it's actually corresponding a path starting from the root. So then go right, go left, go left. So with that said, let's also look at the constraints or additional assumptions for this problem. So the first two constraints actually defines the problem size. So first, the number of nodes is bounded above by 2500. And secondly, the number of nodes in the linked list will be in the range 1 and 100. So in other words, so the linked list has length at most 100. So the third one is on the range of node values in the linked list or in the binary tree. So with that said, actually, we are ready to look at the method and do the analysis. So as we mentioned, we're going to write a solution based on binary tree traversal. So the procedure for this problem is actually very straightforward. So first, we're going to write a hyperfunction. Let's call it f, which accepts two arguments. One is a linked list, the other is a tree. So we're going to use this function to check if there is a continuous downward path starting from the node that matches the linked list. So in other words, this function is a Boolean function. So secondly, we're going to do traversal. So for example, we can do depth first search, for example. So we are going to do traversal for the tree to check if we could find a matching path on a subtree, right? So let's first make a remark before we look at the code. So first, here, this way of writing so actually contains some redundancy. So but for presentation purpose, the logic is clearer and the code is cleaner. So secondly, so the length of the linked list here is bounded above by 100. So this will be okay in the problem setting here. So actually, one could devise slightly complex solution to eliminate the redundancy. So with that said, so let's look at the code. So we are going to split the code into two parts. So the first part is actually the hyperfunction. So let me first write the hyperfunction signature. So it accepts a linked list and a binary tree. So here the function checks if there is a matching path. So starting from a node. So first we're going to check if not head. So in this case, we're going to return true. So this is very straightforward. So if the linked list is not null, but if not node. So in this case, we're going to return false, right? So this is two base cases. So and then we're going to have both the head and node are not null after these two if conditions. Then we're going to check if node value at the head value are equal or not. If they are not equal, then there will be no matching path starting from the node. So in this case, we are going to return false. So otherwise, so we're going to check, because we have matched the node and head in value, then we can match the remaining part of the linked list with the left subtree of node or right subtree of node. So in this case, we can do self call and match head next. So we can consider node left, or we can do head next and consider node right. So that's the logic. So in other words, so if we can match the others in either the left subtree or the right subtree, then we're going to return true. So this is the main part which actually doing the matching path check. So next part is traversal. So we do traversal. So here I'm going to use depth first search in iterative format just for demonstration. So for this, because by the problem assumption, so the number node in the tree is bounded below by 1, so we can actually initialize a stack. So we can put this root in the stack, and then next is actually the basic while loop. While stack, so first we're going to get the node. The node will be stack pop. So we can actually interpret this node as a binary tree. Then we can actually do a logic check. So we can call if helper head and node. Then if this is the case, we find a matching path, so we're going to return true. So otherwise, we're going to check if we can do the match in left subtree or right subtree. So then we can check if node left. So we can actually put the node left into the stack. So stack append node left. So similarly, we can do the check for node right. So let's change the left to right. So that's the main logic. Actually, afterwards, we if nothing has returned, so we can return false. So that's actually the full solution we are going to share. So notice that if we do not have this logic check, then this is nothing but the standard depth first search for binary tree. So first, let's do a special case check. Yeah, it passes the first example. Now let's do a generic case check. Yeah, it passes all the cases. So in this solution, actually, we are doing two things mainly. So first is the hyperfunction, which plays an important role, and then we do a traversal to do the check. So also, actually, we take into consideration of the length of the linked list. So with that said, I guess that's about it for this video. Thank you very much.